Hey everyone, so related rates day 3. We are now going to talk about problems that involve cones and the lamppost problem. All right, and then this is the last two types of related rates. You guys will do some practice on these two, and then we're going to start mixing all the problems in, and I'm not going to tell you what kind it is. You're just going to have to solve. All right, so a conical cup is 4 centimeters across and 6 centimeters deep. Water leaks out of the bottom at a rate of 2 centimeters cubed per second. How fast is the water level dropping when the height of the water is 3 centimeters? So a conical cup really just means we've got this cone. All right. And we know that it's 4 centimeters across, so the diameter is 4 centimeters. And we know that the height is 6 centimeters. Let's see, since the water is leaking out, we want to look at some random level of height here. So if this is some water in there, then we could say that this is the radius, and this would be the height. Okay, because water is leaking out. So we don't know what it is at all points in time. We're looking at a specific point in time, but since those values are changing, we need to put R and H in there. Okay, well, let's think about the volume of a cone. So we know that the volume of a cone is 1/3 pi R squared H, which I'm actually just going to write from now on as pi over 3 R squared H, so hopefully you guys are okay with that. But we have a problem here. When we look at this formula, we've got R squared times H. So if I were to take the derivative, I would need some product rule, and I would need to know information about R dr dt, H dH dt. And if we look at the problem here, we're only given some information at the specific point in time when the height of the water is 3 centimeters, which means I'm going to need to go to my original picture and see if there's something that I can do to help me get my formula so that it's only in terms of H. All right, so this is a trick that we have to use pretty much every time we have a cone problem, but it works every time, which is kind of nice. So we're going to use a proportion here. The radius over the height, so R over H, is just going to be proportional to this radius over this height of the whole thing. Be careful because we were told that the diameter is 4, which means our radius is actually 2. So R over H is going to equal 2 over 6, which simplifies down to 1/3. Now I want to solve that for R so that I can substitute it in here and have this equation only in terms of H. So I'm going to go ahead and cross multiply. So 3R is going to equal H, and then I just need to divide by 3. So I get that R is equal to H over 3. And I'm going to use that in my volume formula. So the volume is pi over 3 times H over 3 squared times H. And now we just need to simplify. So we have pi over 3, H squared over 9 times H, and we can simplify that down then to pi over 3 H cubed. Oops, pi over 27 H cubed. I forgot to multiply the 3 times 9. My bad. Okay, now it's the exact same as the related rates problems we did before. All right, so we drew our picture, we wrote our equation, we got our equation in terms of one variable. Now we're just going to take the derivative. So v prime is going to equal, if I drop that 3, that becomes pi over 9 h squared dh dt. And I'm actually going to call this dv dt. Sorry, I don't know why I put v prime. Old habit. Okay, so let's look and see what we need. dv dt, we need an h, and we need a dh dt. All right, so we were told that the water is leaking out of the bottom at a rate of 2 centimeters cubed per second. Well, because it's leaking out, that's going to be a negative 2 centimeters cubed per second. And then we were told that the height of the water is 3 centimeters. And we're looking for how fast the water level is dropping. So we're looking for dH dt. So we're just going to go ahead and substitute. Negative 2 pi over 9 times 3 squared dh dt. So we get negative 2 is equal to pi, because 3 squared is 9 and it cancels, so pi dh dt. And we can just divide by pi. So dh dt is negative 2 over pi, and it's going to be centimeters per second. And it would make sense for it to be negative because the height is decreasing. So we can always kind of check our answer quickly that way. And that's it. Okay, so let's look at another one. Hopefully it should be easier the second time around. So a funnel in the shape of an inverted cone is 30 centimeters deep and has a diameter of 20 centimeters. So let's go ahead and draw our picture. We know that the diameter is 20 and that the height here is 30. Liquid is flowing out of the funnel at a rate of 12 cubic centimeters per second. At what rate is the height of the liquid decreasing at the instant when the liquid in the funnel is 20 centimeters deep? So again, we need to look at what's happening here. We've got some water in there, and it's got this radius r and a height of h, and the water is leaking out. But here's our water right here. Okay, so the volume is pi over 3 times r squared times h. And again, I only have information about the height of the water. I don't know anything about the radius. So I'm going to have to again look at my proportions. So r over h is going to equal, the radius up here would be 10. So 10 over 30. And so we end up getting that that's 1/3 also. So this ends up being very similar to the one above. So we get 3r is equal to h, and r is equal to h over 3. And we can go ahead and put that into our volume. So again, I'm going quick because it's the same as the one from question 1, so hopefully you're okay with that. We end up getting that the volume is equal to pi over 27 h cubed. And then we can take the derivative, so dv dt is equal to pi over 9 h squared dh dt. And if we go over here, let's see, dv dt, we need h and we need dh dt. So let's see, liquids flowing out of the funnel at a rate of 12 cubic centimeters per second, so that's a negative 12. At what rate is the height changing, so what's dh dt, when the liquid in the funnel is 20 centimeters deep? So h is 20. So we end up getting negative 12 is equal to pi over 9 times 20 squared dh dt. And we're going to do this without a calculator. So we have negative 12 is equal to 20 squared is 400. So we have 400 pi over 9 dh dt. And if we multiply by the reciprocal, we'd have negative 12 times 9 over 400 pi is equal to dh dt. And we know that we can take a 4 out of there and make that a 3, take a 4 out of there and make it a 100. So we would have that dh dt is equal to negative 27 over 100 pi. And then we need our units, let's see, centimeters per second. So that is our final answer right there. Okay? All right, now we are moving on to the lamp post problem. So this again has its own little trick that we have to worry about, but once you know the trick, you should be good. So a person 2 meters tall walks towards the lamppost on level ground at a rate of 5 meters per second. The lamp on the post, is 5 meters high. How fast is the length of the person's shadow decreasing when the person is 3 meters from the post? So this has two questions. That was question 1. How fast is the length of his shadow decreasing? And question 2 is, at what rate is the tip of his shadow moving? So we have two parts here. But let's go ahead and draw a picture of what's going on. So we've got this right triangle, and there's a guy here who's walking towards the lamppost. So this is our lamppost right here, and we can even, if we want, put a little circle above and put some lines coming from it to show it's a lamppost. Let's see, we know that the lamppost is 5 meters, so this is 5, and the person is 2 meters tall. All right, so I'm going to go ahead and call this distance to the left of my person, I'm going to call it x. And the distance between the person and the lamppost, I'm going to go ahead and call that y. So we're going to need to write an equation that relates these two things, and we're going to have to figure out exactly what it is we're doing here. So we're going to use some similar triangles. We're going to use proportions here as well. So we're going to say that x over 2, so his shadow to his height, is equal to this entire distance, which is x plus y, over 5. So essentially what we're looking at is the guy's shadow over the guy's height, and that's equal to the lamppost's shadow over the height of the lamppost. Because if we think about it, if the light is shining this way, then this is the guy's shadow, that distance x. Okay? So that's important to know. Before I take this derivative though, I want to simplify. So I'm going to cross multiply, and I get 5x is equal to 2 times x plus y, which really means 5x is equal to 2x plus 2y, and I get 3x is equal to 2y. So now I've got my picture, I've got my equation that relate x and y, and I'm going to go ahead and take the derivative. So 3 dx dt is equal to 2 dy dt. So for this one, I need to know dx dt and dy dt in order to go along with this. So we were told that he's walking towards the lamppost on level ground at a rate of 5 meters per second, which means that the distance between the guy and the lamppost is decreasing at 5 meters per second. So that's going to be our dy dt, and it's going to be negative. So we're looking for the rate at which his shadow is decreasing. That's our dx dt. So we have 3 times dx dt is equal to 2 times negative 0.5. Well, that's a negative 1, so we're going to divide by 3, and we get that dx dt is actually equal to negative 1 over 3 meters per second. So the length at which the rate at which the length of his shadow is decreasing is negative 1 over 3 meters per second. Now, the second question says, at what rate is the tip of his shadow moving? So now we're looking at this whole thing. So I'm going to go ahead and call this whole distance here z. Okay. So now I'm going to draw this line here, and I'm going to look at, I know that x plus y is equal to z. Okay. Well, now I can take the derivative, so dx dt plus dy dt is equal to dz dt. And dz dt is going to give me the rate at which the tip of his shadow is moving, because his shadow is all the way over here. Okay, so let's see. dx dt, we already know, we found that. That was negative 1/3 meters per second. dy dt they gave us, that was negative, I'm going to write it as a fraction, 1/2 meters per second. So now all we have to do is combine like terms, or well, I'm sorry, get a common denominator and simplify. I don't know where combine like terms came from, I'm sorry. But let's see, I can make this negative 2 over 6, and I can make this negative 3 over 6. So I get that dz dt is equal to negative 5 over 6 meters per second. And there we go. That's the rate at which the tip of his shadow is moving. So you can see that we used the rate at which his shadow is changing and the rate at which the distance is changing to get the rate at which the tip of his shadow is moving. Okay? Question 6 is very similar, but if you notice, parts A and B are switched, so we're going to actually do part B first. So a man is 6 feet tall, walks at a rate of 5 feet per second towards a street light that's 16 feet above the ground. So here we go. 16 feet above the ground. Here's my dude. He's 6 feet tall. And let's see, he's walking towards the lamppost. So I'm going to again call this X and call this Y. And I'm going to use right triangles and similarity to set up an equation. So X over 6 is going to equal X plus Y over 16. And I'm going to go ahead and cross multiply. So 16X is equal to 6X plus 6Y. Right, if I cross multiply and I can distribute. So I get 10x is equal to 6y. And I'm going to go ahead and take the derivative. So 10 dx dt is equal to 6 dy dt. And if I need dx dt and dy dt, we need to talk about what those mean. So let's see, he's walking in at a rate of 5 feet per second, so that's dy, and it's going to be negative. And so dx dt is what I'm looking for. So 10 dx dt is equal to 6 times negative 5. So dx dt, that's negative 30, and then divided by 10 gives me negative 3 feet per second. So remember that we did part B first, so that's actually the rate at which the length of his shadow is changing. Okay? Now if we look back to part A, the reason we did part B first is because that helps us get part A. So again, we're going to go ahead and say that this whole distance here is z. So we know that x plus y is equal to z. And we can go ahead and take the derivative, dx dt plus dy dt is equal to dz dt. And so we needed dx dt in order to be able to find dz dt. So dx dt is negative 3, dy dt is negative 5, and so we get that dz dt is equal to negative 8 feet per second. And that is our final answer there. You might want to flip back to the page that has your useful formulas and put in the volume of a cone. We'll do it in class together too, but that is another useful formula that you'll need. So we're going to do some practice on these specific ones, and then we'll start doing some pull it all together practice. Please come and see me if you need some help, guys. We're getting to the end here, and this is some important stuff for the AP exam. All right, see you later.